In this episode of Cloud Performance Atlas, I help some leaping lizards track down why their bandwidth was off in the weeds. Will we catch what's bugging them? Stay tuned to find out. I got a nice call from the Gecko PROTOCOL team, a B2B company offering a custom, lightweight networking protocol built for gaming and other real-time graphics systems. Their team was seeing lower than expected throughput for their backend machines, which are responsible for transferring and transcoding large video and graphics files. Their architecture worked a little something like this. A client will push about 2 terabytes of data to cloud storage. At the same time, it kicks off work requests to a front end, which leverages a TCP load balancer to spin up a bunch of compute engine instances in a single region to feed on that data, talk between each other, and get the work done. Most of this was working as expected. However, the Gecko Protocol group was concerned about VM to VM throughput, where they were only seeing about 1.5 gigabit per second max connections. I duplicated their setup on my side, which involved a bunch of 1 CPU machines in a single region and ran iPerf on them. The result was about 1.95 gigabits per second, which was much higher than what Gecko Protocol was seeing. Now, I knew from experience that for high bandwidth systems, they were obviously using too small a machine for those efforts, since networking throughput is related to core count. Bumping it up to about 16 CPU machine in the US Central 1 region, I was able to get about 15.9 gigabits per second. Obviously much better. However, when the Gecko Protocol team switched over to this configuration, they didn't see the same results. They only ended up at about 1.6 gigabits per second. After about 20 minutes of a video chat trying to get our configurations identical, the solution smacked us right in the face. The problem was that their team was testing the connection to the external IP of the server, while I was testing on the internal IP. See, if 2 machines are communicating using their internal IPs, then they can send traffic on Google's private internet, which is super fast. Using the public IP, however, forces the data packet to get pushed to the public internet before coming back to the machine, aka not the fastest. When we switched over their configuration to use the internal IPs with the larger machine setup, the bandwidth went through the roof. 15.9 gigabits per second. For Gecko Protocol, this small debugging session resulted in their video and graphics data transfer rate improving by about 14x. For more great cloud content, subscribe to the Google Cloud YouTube channel and stay up to date with other Cloud Performance Atlas video content. Because when it comes to performance, every millisecond counts.